Okay, number 6. Graph the rational function and find the equation of the slant asymptote. Slant asymptotes. What is that? We'll get to that in a second. Okay, these are very similar to the previous problems, 2, 3, 4, and 5. Let's go ahead and try to find vertical and horizontal asymptotes. We always like to do the vertical asymptotes first. Okay, now it's just the bell. Ignore that. X minus 1 equals 0. X equals 1. Okay, those are vertical asymptote. Now again, we look at the degrees here. This time, degree of the numerator is 2. Degree of the denominator is 1. Okay, this time, the degree of the numerator is bigger than the degree of the denominator. If that's ever the case, there's no horizontal asymptote. Again, that applies if the degree of the numerator is bigger than the degree of the denominator. Okay, but in this problem, we're going to have a slant asymptote. Okay, we're going to have a slant asymptote. A slant asymptote will occur when the degree of the numerator is 1 more than the degree of the denominator. So right here, 2 is 1 more than 1. So we're going to have a slant asymptote. To find the slant asymptote, we need to do long division. Or in this case, let's do synthetic division. Let's do synthetic division. Since we have x minus 1, we can just say 1 is the number for our synthetic division. And then we're going to have an x squared. The coefficient is 1. The x term, there's no x term, so it'll be 0. Constant term, there's no constant term, so that's also 0. Let's go ahead and do the synthetic division. Drop the 1 down. 1 times 1 is 1. Add together, 0 plus 1 is 1. 1 times 1 is 1. And we have 1. Okay, so our answer right here, x squared over x minus 1, in our room here a little bit, it equals, okay, looking at all these numbers, that's 1, 1, 1. Again, we always start with 1 degree less than what we had up here. So it'll be x plus 1 plus the remainder, 1 over x minus 1. Okay, when we look at the slant asymptote now, we don't care about the remainder. We don't care about the remainder. We only care about the portion right there. Our slant asymptote is going to be y equals x plus 1. So again, let's repeat that now. Okay, we're looking at the slant asymptote. To do the slant asymptote, we need to do the long division, or in this case, because it's just a linear term, we can do the synthetic division. Okay, so we did the synthetic division, pretty easy right there. 1, 1, 1 was our synthetic division. So right there, x squared over x minus 1 is 1x plus 1 plus the remainder, 1 over x minus 1. Again, we don't care about the remainder. We're only looking at everything else. So y equals x plus 1 is our slant asymptote. So again, let's graph this now. We have a vertical, so we have x equals 1. So that's our vertical asymptote. Now we need to graph our slant asymptote. Y equals x plus 1. So we start at 1, and our slope is 1. Okay, again, these are asymptotes now, so these will we will never touch those lines, but they'll get very close. Now we need to figure out which regions our function is in. So it's either going to be these two regions or these two regions. So let's figure out which one it is. So again, we're just going to plug in some convenient values here. So let's say x is 0. if x is 0, we would have 0 squared over 0 minus 1. That'd be 0 over 1. So one of our points is then, again, if x is 0, then f of x here would be 0. So we know we're at this point right there. Look at that. Let's wait for the bell here. Look at that. So we know we're in this region, and we know it's going to look something like this then. Again, it's going to get really close, but never touch it. Okay, bad graph there, sorry. I mean, again, it's getting closer and closer to the asymptote, but it'll never touch it. Okay, so that's going to be very similar to this side too. Let's go ahead and pick a value. Let's pick 2. So if we have 2, 2 squared is 4. So we have 4 over 2 minus 1, which is 1. So we, again, if x is 2, f of x is 4. So we have 2, 4. And again, it's going to look something, it's going to get very close, but never touch it. Yes, rational functions look a little funky like that, but that's how they are. So again, pick some points. That's how you can know where the regions are going to be.